When we talk about slope between, or a slope of a line between 2 points on a graph, that really doesn't have any meaning. If we're talking about a specific situation where our x and y coordinates actually mean something, then we're talking about something that has some meaning. And even though we're really finding slope, we call this average rate of change because it's dealing with a particular situation. So our first situation here, in 1946, the cheapest World Series ticket was $1.20. In 2012, the cheapest ticket to the World Series was $110. What's the average rate of change of the price of the ticket over time, or over that particular time period? This is really, really easy to do. You take where the thing ended up minus where the thing started. So we take 110 minus 1.2, and we divide that by how many years it's been, which is 2012 minus 1946. And I can maybe do some of this in my head. That 46, that's going to be 54 years, 64, 66 years. And 110 minus 1.2 is 108.8. So what this means is that the price went up $108.80 over a period of 66 years. And if we divide 108.8 by 66, we get 1.6484848, etc. 1.6. I'm going to round that off to 6.5 because we're talking about money and you can't divide it any smaller than that. So the slope of the line, if we were to graph this as a line, would be 1.65, which is not terribly steep. But we're talking about average rate of change. So we're not just going to have a number here. We're also going to be attaching units to it. And it really is easy. It's just the thing that's been changing. What are the units there? Those are dollars. So dollars per, we're measuring in years here, dollars per year. So the price of a ticket to the World Series has been increasing on average by about $1.65 per year. That's not to say it went up $1.65 every year, but if you average out the price increases over time, it works out to $1.65 per year, or $1.65 per year. My math lab is going to ask you for the number, and then it's going to ask you to pick multiple choice what the units are that are appropriate for the situation. Here, we're talking about the average per capita consumption of whole milk in the United States. In 1970, the average consumption per year was 25.3 gallons per person. In 2011, it was 5.5 gallons per person. So it really dropped off quite a bit. Okay, the thing we're measuring, where we ended up minus where we started. So 5.5 minus 25.3. And then how many years it's been? 2011 minus 1970. Well, the years is fairly easy. That's 70 is 30 years and then 41. So the time period is 41 years long. And then I'm not feeling real confident in my mental arithmetic today. So I'm going to do this in the calculator. 5.5 minus 25.3 is 19.8. Negative 19.8. Right? Obviously, the thing went down, so our slope, our rate of change should be negative. We divide that by 41, and we get negative 0.483. And that's approximately, of course, right? Both of those are approximate. Not exactly equal to, but I rounded them off. So negative 0.483. And our units this time are going to be a little bit funky. The thing that we're watching here was measured gallons per person. It was per capita consumption, so gallons per person, and then our time was in years. So I'm not going to write it all out because I'm sloppy today, but gallons per person per year is our unit for this. Right? Fairly simple. Nothing more than a couple subtractions and a division, and make sure you understand what the units are, but the units are fairly obvious because you've got them right in the word problem. Remember, it's the thing that's been changing in the top, and then the number of years, or you might end up with something in days or months, but the time period gives you the numbers for the bottom. And that's it.